shrubby, copy, paste, and etc. Do that for sample 3 and 4, and you'll calculate and spit out. When I use those numbers, those values, this is what I spit out of them. You can't see it all the way, but it's a p-value of less than 0.001.
Try scrolling the box.
So you should get something like this. When you're making your tables too, I haven't tried this, but you may be able to just copy and paste this note summary here, and then paste it here, and then you can change your treatment. So we're clear on how to do the one-way ANOVA and bastard stats. Okay, cool. Let's move on. Percent cover. This is what I was referring to. So now we have open water, which is when you're taking your samples, if you get water or if you get a plant. On your handout, this is actually called covered by species in open water. Do the zones vary in their cover of open water, spectrum loss, plant species, etc. You expect there to be more open water in the cattails and less in the tamarack forest and shrubby zones, right? So for each of these zones, we have 100 total points, right? Versus the transects, where every foot you were taking a measurement of the plant, reporting what the plant was or the open water, remember? So you should have for each zone 100 points. So you had 4 transects of 25, that adds up to 100. So you would add all those up, and again, like I showed you on that last analysis, it might be a good idea to like have a tab with just like all of your data, all of your raw data, and then you can like import it into this and work with it. But I didn't do that for this part. I just made these numbers up. But let's say you had 10, 15, 32, 5 pitcher plants, and then your grass 1 and grass 2 species. These should all add up to 100. Okay? So this right over here is the sum of all these. This one's off because and then you want to calculate your total of these, and that should add up to 400, right? Because you have 4 zones, each with 100 in it. So that's just the total values. That makes sense. Cool. And then let's see the next part. Create a table with a column for the list of species, including open water and stagnant. And a column for each of the 4 zones, and then a column that sums up the entries for each row. So that's basically what this is. A column for the list of species, a column for each zone, and a column that sums up the entries for each row. So that's what these are. For each zone, or column, we put a number of sampling points corresponding to each species. That's what all these numbers are in here. Hence, each sum of 100. Then for each of the 4 zones, the sum across the rows, giving the total number of sampling points corresponding to a species or a condition. So the condition of water is 207 total in this site. And keep in mind, you can do this for every site. This is just say. No, I'm sorry, I don't do the zones. My fault. Sorry. Disregard what you said. All right, so that's this whole table that you just made. That was that first paragraph. The second paragraph. For those species conditions that have a total across all 4 zones of at least 20, create a clustered bar graph with the 4 sites on the x-axis and the number of sampling points on the y-axis with different species conditions as clustered bars. What that means is for any of these conditions or species that occurs more than 20 times in your total, so in this column, then you're going to make a bar graph of those. In this case, we have a lot of open water, we have a lot of sphagnum moss, we have a lot of reeds. Those are the only ones that are over 20. The rest of these are all under 20. So, to make a clustered bar graph, you basically first need to get the average of all these species. So that's just going to be the average across the zones. Cool. Yeah.
So your open water is referring to cat.
What's that?
The open water is referring to cattail.
No. Open water is referring to when you're sampling, if you get water or if you get a open. That's what I'm saying is kind of confusing. Like when you get rid of open. So actually, I'm sorry, you don't need to use the averages yet. And we're not going to have error bars in this one. So you can write a little note, no error bars. If you wanted to make error bars, you can separate this all by trend set. Do the average of trend set, but it's not required here, so don't worry about it. So to make this bar graph, that table that you made that's described really well actually in the bottom, that first paragraph, you have to select all zone 4 for all your species. Insert your cluster bar graph. You have it.
So you said it's not just like in one of the zones and the species says over 20, and you include all the
No,
zones?
not in one zone. So the total of all zones, it occurs more than 20 times in all the zones together.
Oh, okay.
So in that, you'll see that in this total column. This is the total in all the zones, how many times that occurred in all the zones.
So we're creating 2 graphs, right? One for total and the other one for the whole species. Is that what you're saying?
No, don't worry about creating a total.
Oh.
So you're not going to have total in your bar graph. So I'm sorry, that last graph I made, you're right. Actually, you just have to create a graph for the top 3 ones that are over 20, so you just select these. Because those are the only ones that occur more than 20 times.
So my question is, what is that graph? The one that you have at the bottom. Is that a different graph or is it the graph?
No, that's how I made this. I just made it last night.
Okay.
So but I'm just going over how I made that graph. And this graph is, if you do that, it highlights that section. If you highlight all these things and hit insert graph, this thing pops up. And that's exactly what you want. So now you have each of your zones and you have your 3 most abundant species. Yeah, 4 sites in the x-axis, the number of sampling points on the y-axis. All right, so that's graphing of the data. You guys all cool with that? Yeah. So yeah, anything, it says right here, those species conditions, we use by conditions water, not water, they have a total across all 4 zones of at least 20. So the total across all 4 zones is this F column, right? Let's look at that. How many of these are over 20? Just those top 3. So you're just looking at those that are over 20. You may have 5, or you may have 1, depending on your data. But the cutoff is 20, that's according to the sheet, so we're going to follow that. Okay, so we're cool with how to graph this? All right, let's do the analysis. So again, for those species conditions with at least 20 total points, which we just talked about, we're going to perform a goodness of fit chi-square test, which we've done before. We'll have to complete a separate test on each species and condition, and the 4 zones represent categories. Again, the expected occurrence for a chi-square is going to be it's even distribution across all 4 sites, right? So if you recall, we did that in, I think what was that, the Dunes data? Yeah. So to figure out your even distribution, your expected values, you need to find the average, right? So your expected table is going to look like this. We have our 3 species that were above 20, so open water, sphagnum moss, again, water, sphagnum moss, and reeds. And since the average across all 4 zones for water was 51.75, that's what you're going to put for your expected values for all 4 of those zones. Again, the same thing as your sphagnum moss. You're going to take the average of those sphagnum moss across all 4 zones. Turns out to be 23.25 in this case. So that's what we're going to put for all of your expected values for your sample. You guys clear why we're doing that? All right, let's go to Vector stats. So chi-square is going to be the frequency data. Goodness of fit. And then we have observed frequencies versus expected frequencies, right? So, observed frequencies. It's going to be a pain for me to highlight all these because I'm not keeping that. Anybody know? Let's try. What? So that doesn't work. So you're going to have to put them in manually. So let's memorize them. 10, 40, 82, 75. 10, 40, 82, 75. 10, 40, 82, 75. And then what's our expected frequency? 51.75. Alright, so you get all that in. You don't have to put in expected proportion, that'll fill in for you, okay? You hit calculate. These should all be 0.25. In this case, because we have 4 samples, and evenly distributed. And look at the p-value, degrees of freedom of 3, chi-square value. You're mostly concerned with p-value again. In this case, it's less than 0.0001. It's very significant. So you're going to do this for each of these species. So that was the water we just did. So you can do the same exact thing for your sphagnum moss and your reeds. And report all those separately. Okay, so that's the analysis. You guys cool with that? All right, let's move on to the next section. Meter squared sampling quadrat. I do some sorting and stuff for this section, so make sure you kind of keep track of your stuff.